King.com.
Howdy, howdy, howdy. Let's do a little advanced object-oriented programming, and we'll start with polymorphism. Polymorphism. Poly means many. A polygon is a many-sided shape. Morphism is to change shape or form. Polymorphism is the ability of an object reference to change, to morph to another type. Here we see a class diagram. You can see the enemy is the parent class, the soldier, drone, tiger, as well as vampire, mutant. Any enemy object that is coming at us during the game is going to inherit from class enemy. Inheritance is an essential ingredient to polymorphism. You cannot do polymorphism without inheritance. Make sure you understand this class diagram and child classes that inherit from a common parent class. Polymorphism is a common sci-fi movie or TV special effects where you have a character that is a morph or a shapeshifter. Star Trek Deep Space Nine had a character called Odo that could morph into any shape, and in fact throughout that whole series they had a whole bunch of shapeshifters. That's what morphing is shape-shifting, changing form. OOP polymorphism requires understanding inheritance. I'm going to create a class soldier that extends enemy, a class drone that extends enemy, a class tiger that extends enemy. Polymorphism occurs between the object references of objects that have a common parent class. Soldier, drone, and tiger all inherit enemy variables and methods. Let's trace some code and see how this works. When a soldier object is created, it will have all of the enemy variables and methods. Over here in the red underline, I have a soldier object equals new soldier. And follow the arrow and you'll see that I've diagrammed what is in that soldier object. Obviously, it has soldier variables and soldier methods. That's a duh. But it also has enemy variables and enemy methods. Inheritance says if soldier extends enemy, it is also an enemy object. Let's build a drone object. Looking at the red line or the red underline, drone object equals new drone. Follow the arrow and I've diagrammed what's in the drone object. Obviously it has drone variables and methods, but drone extends enemy and it'll have enemy variables and methods. Notice the color coding. The common elements inherited from enemy are in red. Now let's build a tiger object. When a tiger object is created, it will have all the enemy variables and methods. Note that all three objects have the same enemy variables and methods. Looking at the red line, when I build a tiger object, follow the arrow down. The diagram of the object is showing the tiger variables and the tiger methods, but because of inheritance, it also has the enemy variables and methods. And I keep pointing out the enemy variables and methods because that's the key to doing polymorphism, having that common or shared set of variables and methods. I'm going to set up a variable. Look at this underline here. Enemy object equals null. What I'm doing here is declaring an enemy object reference variable. A reference that has not been assigned an object contains the value null. We're basically starting with an empty reference variable here. Look what I can do with this variable. I'm going to say enemy object equals soldier object. Focus on the red underline. I'm assigning to an enemy object reference a soldier object reference. What? Assign a soldier object to an enemy reference variable. Why not? Look at it. It has all of enemy variables and methods. There's an old saying, if it looks like a duck, walks like a duck, and quacks like a duck, it's a duck. Now that soldier object has all the enemy variables. It has all of the enemy's methods. It's an enemy object. There's no reason why I can't assign an enemy object to a soldier object. It has everything an enemy object wants or needs. Now that in itself is just plain old inheritance. Where the polymorphism comes from is on the next line. Look at the red underline. I'm going to say enemy object equals drone object. I'm assigning to the same object reference variable a drone object. That's the morph. Did you see it? The enemy object reference was pointing to a soldier and I just changed it to a drone. The variable enemy object morphed. It's the reference variable that morphed to a drone object. And I want to make this clear. The soldier object did not change into a drone object. You can see that on the thing. The soldier object is still a soldier object. The drone object is still a drone object. What morphed was this red enemy object variable. See that enemy object variable? It was pointing to this soldier. It then morphed to point to this drone. That's the morph. Now here's the polymorph. Oops. Let me fix those dollar signs here. I'll be back in a second. Now let's morph again. Follow the red underline. Enemy object equals tiger object. Assign a tiger object to the same enemy reference variable. That's polymorphism, many changes. The enemy object reference went from a soldier to a drone to a tiger object. Follow the red arrow. I now moved my enemy object reference variable over to this tiger object. That is polymorphism. When you go from a soldier object to a drone object to a tiger object, you're doing polymorphism. And please notice it was the object reference variable that morphed, not the individual objects. There's a reason I drew enemy object in red here. See the red underline and the enemy object variable? It can refer to any object that has enemy variables and methods. Zombie, vampire, mutant, if they all extend enemy, then enemy object works for them. See the variables and methods are in red? That's what the arrows are pointing to. Enemy object can point to any object that contains those enemy variables and methods. Even though the underlying object may be a tiger object, enemy object can reference it. That's the key to understanding polymorphism, that an object reference can morph between objects of different types as long as they inherit from a common parent. Why polymorphism? Why would we do this? What's important about it? Instead of the same enemy every time, let's use a different opponent to mix it up. I could say enemy object equals new random enemy and assign anything to enemy object. This is what we call generic programming. If we always battle the same enemy in the same room every time, it gets boring. What polymorphism allows us to do is much more flexible, much more exciting. We can say, okay, first time you come into the room, you're battling a soldier. The second time you come into the room, you're battling a vampire. The third time you come in there, you got a completely different enemy. There's a tiger in the room. That mixing it up, allowing one variable to be used in many different enemies, is what makes polymorphism a powerful object-oriented programming technique. Let's extend the power of polymorphism to arrays. Let's look at polymorphic arrays. Remember, poly means many, morphism to change shape or form. Let's look at a new inheritance hierarchy. Let's have a parent class shape, and then extend circle, and then rectangle extend shape, and then triangle extend shape. So shape is the parent class, and circle, rectangle, and triangle are going to be the child classes. A classic use of polymorphism is drawing the screen. The next time you play a video game, look closely at the background. It's composed of many circles, rectangles, and other shapes. Think of tiles of different shapes and colors arranged to form a picture. Artists call this a mosaic, and it's how a game can generate a virtual world with thousands of small shapes. We have a class circle that extends shape, and you can see on the diagram the arrow indicates circle inherits everything that shape has. Every variable and every method that shape has, circle will inherit. Class rectangle extends shape. Once again, every variable and every method in class shape, rectangle would inherit. Finally, class triangle extends shape, and triangle inherits all the shapes, variables, and methods. This is how polymorphism works. Multiple child classes that inherit from a parent class, and therefore we could use the same reference variable to point to each and every one of them. Let's create an array of 5 shape objects. Polymorphism means any class that inherits shape can be stored in this array: circle, rectangle, triangle, any shape. So I'll set $screen equal to array and assign it a bunch of nulls as its initial value. This is a newer PHP 5.4 syntax for creating the array. If you wanted to use the older syntax, you'd say $screen equals array, parentheses, a bunch of nulls, end of parentheses, semicolon. Let's just create an array with 5 slots. Follow the red underline. After I create this array, I've basically got the screen array with 5 empty slots, null in each slot. Let's put an object in the array. Under the red underline, $screen subscript 0 equals a new circle object. I'm going to place a circle object into slot 0 of this array. And you can see that following the red arrow that I've built a circle object. Of course it will have all the circles variables and method, but it'll also have shapes variables and method because circle extends shape. Under the red underline, screen 1 subscript 1 equals new rectangle. Since rectangle inherits all of shape's variables and methods, assigning a rectangle object to a shape array element is legitimate. Remember, if it looks like a duck, walks like a duck, and quacks like a duck, it's a duck. If rectangle has all of shape's variables and all of shape's methods, then it can go into this shape array. Following the red arrow down to the visualization of the actual rectangle object in slot 1, you can see it has all of shape's variables and methods. Triangle has all of shape's variables and methods too. It is a shape object and can be assigned to a shape array. So looking at the red underline, screen array subscript 2 equals new triangle. Following the red arrow, you can see triangle has all of shape's variables and methods. Certainly can be inserted into a shape array. Filling the array with additional objects, any object from a class that extends shape can be assigned to any slot of this array. Screen subscript 3 equals new circle. I pluck another circle object into the array at position or slot 3. Finally, I insert into $screen index 4 a new triangle object. A triangle object can go in that array because it has all of shape's variables and all of shape methods. This array could be filled with 5 rectangle objects or 3 triangles and 2 circles. For example, a brick wall could be created by storing many rectangle objects in a larger, not just 5, $screen array. Hopefully you can see I can put any objects that extend shape into this array. If I'm in a video game and I see a brick wall, look at a brick wall closely next time. It's just hundreds of rectangle objects. And you can draw anything out of circles, rectangles, and triangles and form any scene you want. That's how we build these virtual worlds. By drawing hundreds if not thousands of tiny little shapes on the screen, you can build whatever world you want. Going back to the question we always ask, well, why? Why do we want to do this? Well, here, we'll show you why. What can we do with an array shape? Each shape object has a draw method. Let's make sure that every shape object, circle, rectangle, and triangle, has a draw method. Then a simple for loop will spin through each slot of the array and call that draw method. Let's trace a little code here. For $I equals 0, $I less than count of $screen, $I plus plus. This is a for loop that will loop through every slot of that array we just created. And for each slot of the array, it will draw something. Watch it in action. $I now contains a 0. 0 less than 5 is a true statement. As a true statement, I'm going to go inside the for loop and execute that draw. All right there, did you see my little edit there? I had a little syntax error, so I fixed the code, but I'm back. Let's access the object at index 0 of the array and execute its draw method. Look at the line with the red underline. I'm going to go to the $screen array at position 0 or $I. I want to run that object's draw method. Well, if I go to that object here, there's position 0, it's a circle. When I call the circle's draw method, well, look what it showed up on the screen, a circle. Looping back up on the for loop, we're going to set $I equal to 1. The plus plus will increment I. Checking the for loop, I less than 5 is a true statement. The count of the number of items in the array is 5, so that is absolutely true. We're going to go inside the for loop and execute the code once again. But this time, we'll access the object at index 1 of the array and execute its draw method. Follow the red line here, go to the array, position in 1 this time, and execute its draw. Follow this reference from index 1 down to here, and I see a rectangle. And I see the rectangle method draw. And the rectangle method draws a rectangle. It uses the x and y coordinate that it inherited from shape. It uses the width and height that it created, and it draws a rectangle on the screen. Looping back up, we'll increment I. $I will go to position 2 of the array. 2 less than 5 is still a true statement, so we're going inside the for loop to execute what's inside the for loop. Getting inside the for loop, we'll access the object at index 2 of the array and execute its draw method. Go to the screen at position 2, and at position 2 we run its draw. If you go here to position 2 of the array and follow the reference, it's a triangle. Wow, we'll use the base and height variable of the triangle and the x and y position inherited from shape, and we'll execute the triangle's draw method, which of course draws a triangle on the screen. This triangle object here will draw that triangle right there. What else do you expect a triangle object to do but execute a draw of a triangle? Looping back up, $I goes to 3. 3 less than 5 is still a true statement, so we're going back into the for loop. And this time we'll access the object at index 3 of the array and execute its draw method. Well, follow the reference at index 3. It's a circle. I'm going to use the radius and the x and y position and draw another circle on the screen. This is a different circle object, so it will draw a different circle. It has a different x and y position, a different radius. There goes our circle. Loop back up, $I will go to 4. 4 less than 5 is still a true statement. We're going into the body of the loop to execute the code in the loop. We'll access the object at index 4 of the array and execute its draw method. If you follow the reference at index 4 over to the object, it's another triangle. It'll have its own x and y coordinate. It'll have its own base and height variable, and its triangle method will draw another triangle on the screen. Get in the picture? It's very easy to draw hundreds, if not thousands, of these things on the screen. Now, I don't have room to put 1,000 objects on the screen, but if I did, I could draw a pretty elaborate 3D world. $I goes to 5. Now that's interesting. When I now execute 5 less than 5, it is a false, and it's going to get out of that loop. It'll stop executing the draw method. Using the count of $screen may not be the best here. It always assumes the array is full. Maybe a $num variable with the number of objects may be better. That way, if there's 3 or 2 or 5 objects in it, I'll loop to $num instead of through the entire array. Other way you could improve this is you could add a check for null if there was an empty slot. Right now, all the slots of this array are occupied. But if there was an empty one, there might be a null in here. I might put an if statement in here that says, hey, if this object is not null, go ahead and call its draw method. Either way, you got to find a way to draw some or all of the objects of the array. Now we know 2 things for sure. Number 1, I'm a terrible artist. What the heck is that? Kind of a smiley face, kind of a jack-o'-lantern. I don't know what it is myself, and I drew it. And number 2, simple code can draw many, many different numbers and types of shapes to create the virtual video game world. That's how the favorite game that you play creates those elaborate 3D worlds. What you're looking at is 1,000, maybe many thousand shapes drawn on the screen. And all it takes is some simple code that says, from start to finish, draw each one of those shapes. You take a step forward, it redraws them slightly bigger to give the illusion of going forward. If you take a step backward in the virtual 3D world, it draws them again slightly smaller to give the illusion of backing up. This is what I like about object-oriented programming. Once you get it right, very simple code can do very, very powerful things. Imagine if this loop was drawing 3,000 shapes. What sort of virtual world could you draw? Abstract classes. Now we're really getting deep into advanced object-oriented programming. An abstract class is a class designed specifically as a parent, base, or superclass. They do not create direct object instances. They exist as a child object. Abstract classes make polymorphism even more powerful. My diagram here is very generic. A concrete class is an actual object that is created out of an abstract class. The concrete class extends or inherits the abstract class. Let's look at an example. We're going to add a new keyword here. The keyword abstract. If you look at the red underline over here and the arrow, I'm going to put the keyword abstract in front of class. And by putting the abstract in front of class, it's going to make this an abstract class. This is a generic example of creating and using an abstract class. Using the keyword abstract when creating the class makes it an abstract class. These are just code snippets. This is not a full example. These are just little pieces so I can show you the minimum amount of code so you can understand how abstract classes work. The primary purpose of an abstract class is to be the parent class when doing inheritance. Use the extends abstract class to create one or more new classes from an abstract. If you're not doing an inheritance, there's no reason to create an abstract class. The reason I put the comment / yes at the end of this red line is this is exactly where you use an abstract class. You extend abstract classes. That's the reason for creating an abstract class. I don't like to show you wrong things, but this is what you don't do with an abstract class. This is what you can't do with an abstract class. That's why I drew that big red X through it. A direct object instance is not, I repeat, not created from an abstract class. Never use the new operator in front of an abstract class. Remember, abstract classes are for inheritance, not for creating direct object instances. What I'm trying to do is create an abstract class object here, and it's simply not allowed because of this keyword abstract over here. Where you use an abstract class is after extends. You do not use it to build an actual object. But don't worry, you can build an abstract object, but you have to do it through a child class. Remember, polymorphism means you can assign a child class object to a parent class reference variable. That's how an abstract class becomes an object. The object built from the child will have all the variables and methods of the abstract class, so it can be assigned to a variable of type abstract class. Look at this arrow. The reason I'm assigning the child object to this variable here is because it extends the abstract class. And therefore this is essentially an abstract object, but it only lives through the child class. If you look closely at the diagram that I drew here, this is a child object. I say new the child, so it's going to have child variables and child methods. But because of the extends command above, it's going to have the abstract class variables. It's going to have the abstract class methods. Therefore, $object is essentially a child object and an abstract class object. The only point I'm trying to make with this entire slide is they become objects through the child class, not as direct object instances. And again, it's that keyword abstract. What prevents it from becoming a direct object instance. Let's look at a real example. Let's make abstract class enemy. This used to just be class enemy. Now it's going to be abstract class enemy. Using the keyword abstract when creating the class makes it an abstract class. What we're going to do is place common or shared code in enemy, and then all the child classes, vampire, drone, etc., inherit from it. We'll put the specific or unique code in the child classes. For example, neck biting goes in the class vampire. Soldiers don't bite necks, drones don't bite necks, mutants, well, they might. But anyway, vampires bite necks. Anything specific to vampire, we're going to put in the vampire class. Class vampire extends enemy. Now the enemy is an abstract class. That's its primary purpose, to be extended. We'll use the abstract class enemy to create vampire and many other classes. Drones, mutants, soldiers, tigers, everything. Boring game would have 2 or 3 opponents. An interesting game might have 10 or 20. What we want to do is build many classes from enemy. Anything that tries to hurt or damage the main character should inherit from the abstract class enemy. This is just one example of creating vampire out of enemy. All the other enemies that we battle in this game will inherit also from enemy. Since we went ahead and made enemy abstract, we are no longer allowed to build direct enemy object instances. See that big red circle with the red cross through it? You cannot say new enemy object anymore. That is not allowed. A direct object instance from an abstract class enemy can never be created. This is an error and it will signal it as an error. The reason number one that we can't do it is the compiler will refuse to compile any code instantiating an abstract class. When you go to run this program and say, I can't run it, you're building an abstract object. Reason number two is enemy's going to be incomplete. It needs specific code from the child classes, vampire, soldier, drone, etc. And it just doesn't have it. We'll see more specifically what that means when we get to abstract methods. But let's, for now, point out that enemy is not ready to become an object. And we do not make direct object instances out of the abstract class enemy. But we can still make it an object. $object equals new vampire. Follow the red line, the red underline here. We're going to build a vampire object. But remember, vampire object extends enemy. It is also inheriting the enemy variables and the enemy methods. If you look at my visualization of the object, there's the enemy variables there. It's there. Polymorphism means you can assign a vampire class object to an enemy class variable. Since the object will have all the variables and all the methods of enemy, get used to it. Almost always when using abstract classes, child objects are assigned to parent class reference variables. It's not like enemy can no longer be an object. It just has to be an object through the class vampire, through any child class. Read the comments up here. Yes, we extend an abstract class. No, we don't build direct object instance out of it. But yes, we do build objects out of the child classes. The same thing works with arrays and any other class that uses inheritance and polymorphism. Let's do the same thing. This time let's use it with the class shape, and let's put the variables into an array. Here's the pattern. Look at this pattern. The pattern is we create an abstract when you plan to create multiple similar child classes. Out of shape, we're going to build circles, rectangles, triangles, etc. Out of enemy, we build vampires, drones, mutants, etc. Out of a parent class gun, we might build a pistol, a shotgun, a rifle. Whenever we plan to build multiple classes that all have something in common, we're going to build abstract classes out of the parent class. Follow the red underline. The big change here now is we're putting the keyword abstract in front of class to say shape is now an abstract class. That's no problem. When we create class circle, we'll still extend shape. Yes, this is where we use an abstract class. We use an abstract class after the keyword extends. That's how you properly use an abstract class. We want to build our screen array. Now I'm using the PHP before 5.4 syntax. Again, this equals array says create me an empty array. I'm going to create $screen equals array. This is going to be an empty array, an array with nothing in it. This is going to be my array of shape up here. Here's another pattern. The derived class objects almost are always assigned to base class variables or arrays. Any derived class that extends shape, circle, rectangle, triangle, is going to be assigned to any array slot in this array. We're going to fill this array with objects and use a simple loop to draw the screen. I'm going to go to $screen subscript 0 and insert a new circle object in subscript 0 of this array. Everything drawn on the screen is going to be an object from this array. Since a circle object has all the shapes, variables, and methods, you can see it right there. If you look at my diagram, this circle object still has shape variables and shape methods. Since it has all the shapes, variables, and methods, it can be assigned to any slot of this array. Each screen or level of the game is composed of shape objects. When I want to build a new screen, I'm just going to fill the array with different shapes. Then I'll go to $screen subscript 1 and assign it a rectangle object. What I'm doing is assigning a rectangle child object to an array of type shape. The beauty of this pattern is that even during gameplay, if I add something to the array, bam, it shows up on the screen. If I remove an object from the array, bam, it goes away. I can put things into this array and take things out of that array, and next time I draw it, I will reflect the change on the screen. It's a very, very simple, straightforward design. Once you understand object-oriented programming, you can do very, very powerful things with a tiny little piece of code. But wait, there's more. The real power of abstract classes comes from an abstract methods, and those are next. Watch what we can do when we add abstract methods to this madness. Abstract methods. An abstract method is declared in the parent class and written in the child class. It's prototyped in the superclass and implemented in the subclass. It's the parent class forcing the child class to do something. Now think about it. What chores does your dad or mom make you do? Do they make you wash the car or mow the lawn or clean the room? My dad had a favorite saying, "If you're gonna live in my house, you gotta follow my rules." And that's what's happening here. Look at these two diagrams. One is you and your dad. Your abstract dad is telling you to wash the car, mow the lawn, or no playing video games. Now you inherit from your dad. So the child you says, darn, I have to wash the car and mow the lawn. I really, really want to play video games, and dad's not going to let me do it until I wash the car and mow the lawn. That's what I mean by an abstract method. The things that the parent forces the child to do, those are the abstract methods. Looking over on the right side, the diagram on the right side, we're back to computer programming. Abstract class. An abstract class is, as we said, a class created with the keyword abstract. And the abstract class says you must write a move method. And the abstract class says you must write an attack method, or I'm not going to compile. I'm not going to run. If you're a concrete class, a class that extends an abstract class, darn, you're going to have to write that move or an attack methods. It's a requirement. Just like your dad forces you to wash the car and mow the lawn, this abstract class here is going to force the concrete class to write a move and attack method. Here's a stripped down example. Remember, I don't put all the code into these examples because then the code would be too big to show up on one slide. But I can fit sort of a snapshot or snippets of it in there. In order to create an abstract method, you have to have an abstract class. Any class with at least one declared abstract method is going to be an abstract method. Looking at the red underline over here, we are going to be an abstract class enemy. And again, that keyword abstract in front of class says this is an abstract class. Inheritance says common or shared code belongs in the parent class, and specific or unique code belongs in the child class. What do all enemies have in common? Well, all enemy objects in a video game are trying to attack you. That's what makes them an enemy. It's a soldier firing a gun at you. It's a vampire trying to bite you. It's a tiger trying to slash you. Don't they all attack differently though? I can't really write one attack method up in the enemy that will do all the different types of attacks. So what I'm going to do here is create a public abstract function attack. And notice the semicolon at the end. All I'm doing is declaring an attack method here. And what that means is the child class is going to have to write that method. Notice the semicolon at the end of attack. An abstract method attack is declared and prototyped in the parent class. Any child class then must write that method or the child class will not compile. The keyword abstract is required in this instance. If you want to make an abstract method, you're going to have to use the keyword abstract in front of the word function. What this is it's the class enemy insisting that all child classes, zombie, drone, soldier, etc., provide their own version of the attack method. In the case of a zombie class, it's going to attack you by eating your brain. If it's a drone class, it's going to attack you by firing a missile. If it is a soldier class, it's going to attack you by shooting a gun. There is no way to write one generic attack method. So I'm going to create an abstract attack method in the parent class, and I'll let the child class define what the attack means. Looking at the red line there, I'm going to create a public abstract function move. Notice the semicolon at the end. I am not writing the move method. I'm declaring or prototyping the move method. And we're going to put this in the parent class. Inheritance says common or shared elements belong in the parent. And we want all enemy objects to move. So we're going to declare abstract move in the parent class. So we make sure that everybody has a move method. But a zombie moves in a slow, dim-witted manner. A drone flies, hovers, moves up and down. A soldier walks, jogs, or runs with a purpose. They all move differently. Inheritance says specific or unique elements belong in the child. What we're going to do is write a move in all the child classes and make it behave as that object would move. Zombie move method will move like a zombie. The soldier move method will move like a soldier. And the drone move method will fly like a drone. Are you seeing it? The key here is we're making them abstract in the parent class. That will make them required in the child class. It's the parent forcing the child to do something. If your dad forces you to mow the lawn and clean your room, a class enemy is forcing its child to write an attack and move method. Let's be clear here. This is not the entire enemy class. I underlined the comment other enemy stuff. All the other stuff we've been seeing in the enemy class, X position, Y position, health, all that stuff is still there. But I just want to show you the essential parts or elements needed to declare an abstract method as shown. There's not enough room to also list all the variables that we might have, plus the get and set methods and everything else that is there. But they're there, and the move method will be using them to change the location of the enemy object on the screen. Keep in mind this is a snippet of the class enemy, and there's plenty of other variables and functions and methods in this class. Now let's see what we have to do. Class zombie extends enemy. Look at the red underline. What do we have to do when zombie extends enemy? Hopefully it's obvious. To use an abstract method, a child class is required. The abstract method says somebody's got to write this, and that's going to be zombie. When zombie inherits enemy, it is required to write the abstract methods declared in enemy. This is a rock solid guarantee. Zombie will not compile, zombie will not run without the abstract methods declared in enemy. See the attack and move methods up there in enemy? Because they're abstract, zombie now has to write those methods. Plus, any other class that extends enemy will also have these guaranteed abstract methods. Vampire extends enemy, it will have an attack and move method. Notice the arrow and what it connects. The declaration of the abstract method attack in the parent class means zombie is required to write or implement that method. This public function attack in zombie is not optional. Because it was abstract in the parent class, this is a requirement. And any other class that extends enemy, drone, soldier, vampire, will also have that guaranteed attack method. And of course, I would expect this method to behave like a zombie would behave. Put a comment in here under the red line, zombie must write attack. When a zombie attacks, it tries to eat your brain. It's what they do. The attack method should implement brain eating. In the class drone, the attack method should launch a missile. In the class vampire, the attack method should try to bite a neck. In the class soldier, the attack method should fire a gun. It's very important that you understand that child objects behave like what they represent. A child class contains the specific code, and brain eating is very, very unique to a zombie. We'd expect a zombie attack to implement the code to eat a brain. I would expect a soldier attack to fire a gun. I would expect a vampire attack to bite a neck. What about move? Notice the arrow again. Because it was declared abstract in the parent class, zombie is now required to write move. This is not optional. The declaration of abstract method move in the parent class means zombie and all child classes are required to write or implement the move method. Inheritance says the common or shared code belongs in the parent class. Well, all enemy objects move. They all move. So it is declared in the parent class because all enemies move. Inheritance, though, says unique or specific code belongs in the child class. All enemy objects move differently, so it's implemented in the child class. A zombie, once again, moves in a slow, dim-witted manner. A zombie moves very different than a tiger does. I want to implement how a zombie moves in this move method. We're going to write the code in here to implement the move. Like I say, it moves in a slow, dim-witted, dragon-afoot manner. The move method should reflect this behavior. In the class tiger, the move method should stalk at first, then go much faster when chasing. In the class drone, the move method should fly, hover, go up and down. See what I'm doing here? If it's something unique to the child class, you need to put that code in the child class. But they all move. Abstract method in the parent class that says you, the child class, must implement this move. What if I created 10 classes that extend enemy? Then you will write 10 different move methods, and each move should behave as expected. If I built a class landmine that extends enemy, the move might even be empty. Landmines just sit there. They never move. I just might build just an empty move method in the class landmine. Getting the idea? If it's common, it goes in the parent. If it's unique, it goes in the child. Sometimes we want to mix the two. They all attack, they all move. We declare it in the parent as abstract, and then we know for sure each and every child class will have those two methods. And to be clear, this is not the entire zombie class, just the essential elements to implement the abstract methods are shown. There's not enough room to also list all the other zombie specific code like moaning brains when they want to feed or coming back to life after they're killed. There's a lot more code in this zombie class. What I'm showing you is a snippet of what I need in order to do an abstract method. Any variable or method specific to zombie would be in this class. In addition, you're guaranteed to have the required abstract methods in this class. In order to have a zombie at all, you have to have an attack and move method because it was required by the abstracts in the parent. Let's go back to our shapes, but let's extend shape. Let's build real actual things out of the shape class this time. This example also uses inheritance, polymorphism, and abstract methods. We're going to create a class shape, which will be the parent class to anything we want to draw on the screen. In a 3D game, this would build a screen using things like circle, rectangle, and triangle. But in a simple 2D game, you could use elements you see on the screen like house or tree. 3D games are a lot more involved. You build the screen out of very basic circle, rectangle shapes. 2D games are a lot easier to code. You can build actual things that appear on the screen and put those in the shape array. Notice this diagram here. We're still going to have our shape parent class, and we're going to have an abstract draw method in it. But this time, instead of building circles, rectangles, and triangles, let's build a full house and extend shape. Let's build a tree and extend shape. Let's build a cloud. Things that would appear on the screen, let's build them and put them in the shape array. We'll declare it as an abstract class shape. Notice the line, the red underline. Notice the arrow that indicates this is an abstract. That'll allow us to create a public abstract function draw and make draw an abstract method. And then we'll have a required draw in every child class object. The abstract method draw will make sure everything that extends shape has a draw method. Kind of important because these are the objects we want to draw on the screen. Once again, we're talking code snippets here. This is not a complete coding example, just the required pieces to show you how abstracts work. We need an array. We need an array of shape objects. The array is the key at the start of each level of the game. You'll load the array with the objects you want shown on that level. And this way, one program can display many different level screens. Building a new level is as easy as loading a different list of house, tree, cloud, etc. into the array. So notice the red underline. I'm going to be creating an array. Array fill says just create a 500 element array with a bunch of nulls in it. That's it. I've got an empty array with a bunch of nulls in it. When I load up a level of the game, what I'm going to do is take that empty array and fill it with objects. So a house went into slot 0, and a cloud went into slot 1, and a tree went into slot 2, and another house went into slot 3. At the start of each level, what I'm going to do is I'm going to load this array with objects, things that I want to see on the screen. Well, if I have this array loaded with objects, what can I do with it? Let's do our simple for loop. Start at the beginning of the array or list of objects we want to draw on the screen and go down the list and draw them all on the screen. I'm going to say $I equals 0, and I drew that arrow there underneath the red line to indicate that we're selecting the object in slot 0. We'll say $I less than num shapes. The variable num shapes tracks how many objects are currently in the array. If the level only had 100 objects, we don't want to loop 500 times. Num shapes is going to be a variable that keeps track of the total number of things in our array. Right now you can only see 4 of them, but the ... indicates there's more shapes in there. You can't build a nice level screen out of just 4 things. You've got to have hundreds, maybe thousands of shapes in that array. Since 0 was less than num shapes, this was a true statement, we went into the for loop, and the red line indicates we're going to execute this line of code. We're going to go to the screen array at position 0 and execute its draw. Since it's abstract, it automatically executes the draw in the house class. Using the variables like x position and y positions are part of the objects to place it in the right spot. Again, I wish I had an arrow here, but we're going to this guy right here. $I is 0, so we're going to this object. It's going to have an x and y coordinate, like this x and y coordinate right here. It's going to have an image of the house, and it's going to execute a method called draw. And of course, if you're a house object and you call draw, it's drawing a house. Looping back up on the for loop, we're going to do the I++. We're going to change I to 1, which will move to this slot of the array with the cloud object in slot 1. 1 less than num shapes is still a true statement, so that's going to go into the for loop and execute the draw again. This time we'll go to position 1. It'll go to the object in slot 1 of the array and execute its draw. Since it's abstract, it automatically executes the draw in the cloud class. See this red arrow up here? The shape in the array is a cloud, so it goes down to the cloud and runs its draw. You can see it over here. Slot 1 goes to here. I'll use the cloud variables and the shape variables and the cloud methods and the shape methods. When I execute draw of this object, it puts a cloud on the screen. Using the variables like x position and y part that are part of the object, and it'll place the cloud exactly where I want it shown. $I++, $I is going to 2. That means we're going to be going to the object in slot 2 of the array, and if you follow the reference from slot 2, this is a tree object. So guess what it's going to draw? At this point, a true statement again, 2 less than whatever number of shapes is true. So we're going to go down into this code and say go to the screen array, position 2, go to that object and execute its draw method. Notice the red arrow up here. The object in the array slot is a tree, so it's going to execute the tree objects. Since it's abstract, it automatically executes the draw on the tree class using variables like x position and y position that are part of the object to place the tree in the right spot. Now I've gone through 3 slots of the array, a house, a cloud, and a tree, and you can see I have a house, a cloud, and a tree. Changing I, it's going to become a 3. We're going to be pointing to this object in that slot of the array. Still a true statement, 3 less than num shapes, that's true. So the loop will execute again. We'll go into the body of the loop and execute that draw. It'll go to the object in slot 3 of the array. The object in slot 3 is a house, so it's going to go to the house draw method. Or if you want to look at it over here, there's slot 3. We're going to go to this object and execute its draw method. Since it's abstract, it automatically executes the draw in the house class using the variables like x and y position. Now here's an important thing to understand. The house object in slot 0 had a different x and y variable. The house object in slot 3 has this x and y coordinate, so the house draws at a different spot. Getting the picture? At this point the loop would continue. If there were hundreds of little shapes, I'd draw hundreds of shapes and I could build a pretty elaborate screen. When used together, inheritance, polymorphism, and abstract classes and methods means simple code can generate amazing level screens. Again, I can't do it all on one tiny little slide, but what if I had 200 shapes like this? Imagine the screen I could build out of 200 shapes like this. Inheritance levels. Inheritance can have many levels. Abstract methods determine if you go up or down a level when trying to locate a variable or method. Look at this inheritance diagram. According to this diagram, the class child extends parent. And according to this diagram, the class parent extends grandparent. Inheritance is a hierarchy. You can have a parent class, a grandparent class, a great-grandparent class. In PHP, you can only extend one class at a time, but if you extend a class that extends a class, you inherit from all of the classes. What we're going to do is look at how this affects abstracts and how it just normally works in inheritance. Here's our diagram here in a slightly smaller version. We're going to have sniper extend class soldier, and we're going to have soldier extend class enemy. Once again, we'll create an abstract class enemy. Notice the red line. We're creating an abstract enemy. Enemy in this case is at the top of our hierarchy. Sniper is down there at the bottom. In class enemy, we're going to create an abstract function move. We've already done this before. This should be nothing new. But here is something that's new. Using the keyword abstract, when declaring, note the semicolon, a method means a child class must write or implement that method. The class soldier extends enemy. Because soldier extends enemy, it is required to write a move method. Soldier will not compile without move. A soldier object should behave as expected and walk, march, or run when move is called. Just think about how a soldier moves in a video game that you've played before, and that's what we're going to implement in the move method. But now we're going to create a class sniper that extends soldier. Sniper is a special type of soldier. So it's going to extend soldier to inherit the things like name, rank, and serial number. But a sniper doesn't move. What a sniper does is they hide and they camouflage you in one spot. In this case, the move method for sniper might be empty or keep the sniper in the same X and Y location. We want a sniper object to behave like a sniper, and snipers are very different. They hide in one spot and fire from that spot. Even though sniper extends soldier and soldiers move about, we want the move method in sniper to stay still and stay camouflaged. Let's build an object equal new sniper. Follow the red line under here. We're going to have an object created out of the sniper class. We're creating a sniper object that inherits from soldier and enemy. A sniper object will have the variables and methods from all 3 classes, including 2 move methods from class soldier and from class sniper. Also note it's assigned to a reference variable of type sniper. We are definitely building a sniper object here. But if you look at my diagram of the object, it's going to have all the enemy variables and all the soldiers variables. And now it'll have all the sniper variables. When sniper extends soldier, it picks up soldier's variables. When soldier extends enemy, it picks up enemy's variables. Same thing for the methods. What we have here is an object that has 3 sets of variables and methods. That means we got to be careful how or what methods we execute. Underlined here, $object, go inside this object and execute the set exposition method. Set the exposition method for 400. The variable object is of type sniper. Clearly we built object out of a sniper class, so it is of type sniper. The first place it's going to look for set exposition is sniper. It's a sniper object running set exposition, looking class sniper. But set exposition is not in the sniper class. So what it's going to do is move up the ladder and look for it in the parent class soldier. Still trying to run the method set exposition. Set exposition is not in the class soldier. What? It's not there. So again, it'll move up the ladder and look for it in the parent class enemy. Moving up the ladder, set exposition will be found in class enemy and run from there. Method set exposition is located and executed. It was inherited from an enemy all along. This is standard behavior for a normal method. If I go to an object and say run this method, it will move up the inheritance hierarchy to locate and execute the method. The inherited variable exposition will get the value 400. Sniper has all the methods, so if I go to a sniper object and say run a method, if it's not there, it goes to soldier. If it's not there, it goes to enemy. When it finds it, it executes the inherited method. That's normal behavior for a regular method, to go up the inheritance hierarchy looking for and executing a method. Just to show you something new, this line of code does not create an object. Focus on the line underlined in red. This line of code does not create an object. It simply declares another reference and points it to the same object created above. The references $object and $same point to the same object. If you look here at my diagram, $object is pointing to the same object that $same is. I'm going to execute same.move. Reference variable $same can be any enemy type. It could be a soldier object, it could be a vampire object. In this case, it's a sniper object. It could be anything. Since move is declared as an abstract, it's going to start at type enemy and look for the move starting at class enemy. Always start with the abstract reference when you execute an abstract method. So we're going to start at enemy and go down the ladder. Since move was declared abstract, you can see it's abstract right there. Since move was declared abstract, it's going to go down the ladder. It'll go down the inheritance hierarchy to run the method. Normal methods go up the hierarchy. Abstract methods go down the hierarchy. So moving down to the move, since move is abstract, it'll go down the inheritance hierarchy to run method. And soldier, it's going to find a move method. But since sniper wrote the move method, it will skip soldier and keep going down the ladder until it finds the sniper's move method. Went down the inheritance hierarchy as far as it could go to execute the method. In sniper, the move method does nothing. It just stays there. This is called overriding. Since sniper should stay in the same location, it's overriding the behavior of a soldier. That's what an abstract does. It says move down the inheritance hierarchy and run the method as far down as you can go. A normal method moves up the inheritance hierarchy. If you don't have it in your class, you go up to the parent class and see if you can run it. An abstract moves down the inheritance hierarchy, looking for the method to execute. Interfaces. This is another new feature. It's 5+ of PHP. If you're running an old version of PHP, you're not going to have the interface. It's a way for unrelated objects to communicate. It's sort of an inheritance light, or like a pure abstract class. In this diagram, we're going to have a class object A here on the left, and of course it's going to have object A variables and object A methods. But now we're going to add something new. We're going to interface X methods. Object A is going to implement an interface, and we're going to have methods from that interface. Now over here on the right, we have a class object B, completely unrelated to object A. Of course, it's going to have object B variables and object B methods, but it also is going to implement interface X. Since they both implement interface X, you can see they both have interface X methods. Object A and object B can talk to each other using their common interface X methods. It's a lot like inheritance. When multiple classes inherit from the same parent, they have this sort of shared set of methods. Well, an interface does the same thing without the inheritance. You don't need to inherit the methods. You can implement the interface. So let's look at the red line here. We're going to create an interface explode me. Look at the keyword. The arrow is pointing to the word interface. The keyword interface is used to create explode me. An interface is like a pure abstract class. Now I put like in quotes there because it's not a pure abstract class. It only behaves like one. Similar to an abstract class in that any class that extends an abstract class must write the abstract methods. Any class that implements an interface must write the interface methods. Remember this idea of an abstract method. It's like the parent forcing the child to do something. Well, with the interface, it's the interface forcing the child to write the methods. Inside the interface explode, we're going to create a public function doExplosion. This is a declaration of the method doExplosion. Note the semicolon at the end. We're not writing this method, we're declaring or prototyping it. Any class that implements this interface must write this method. That's it. All you have to do is write that method. You do not declare any instant variables of an interface. You do not write any normal methods in an interface. You only define methods in an interface. It's like a pure abstract class. It is not a pure abstract class. There's no keyword abstract inside the interface. Notice how you didn't have to put the keyword abstract here. Well, it's assumed. The only reason we don't have to put abstract here is because since it's an interface, all the methods inside of the interface have to be abstract. It would be redundant to put the keyword abstract on that. What you do with an interface is have a class implement it, which means zombie must write the method doExplosion. Focus closely on the line in red underline. Class zombie extends enemy. We all know what that does. But now we're going to implement explode me. Since we're using this keyword implements, what follows that is this interface explode me. Explosions are a part of video games. Class zombie now must write a method that animates what happens when a zombie gets hit by a grenade or steps on a landmine. We want this zombie to explode. Implementing the interface means it must write the method doExplosion. Lots of things can blow up. What we have an interface do is have a class implement it. Now in this, focus on the red line, we're going to have a class house that extends shape, completely unrelated to zombie, but it also is going to implement explode me. If only enemy objects blew up, we wouldn't need an interface. But a house or any other elements that appear on the screen get hit by grenades too. The class house must now write a method to animate an explosion. This is why I kind of call it inheritance light. You don't want all the other stuff you would get by extending enemy. All you want to do is implement an explosion method. Well, implement it, and the only requirement of the implements command is you must write these abstract methods, the methods listed in the interface. Let's do a little inheritance polymorphism review. Because zombie extends enemy, it can be assigned to a type enemy reference variable. I'm going to say enemy object equals new zombie. On this red line, you'll see enemy object equals new zombie. This is an enemy type object. If a zombie has all of the enemy variables and methods, it certainly can be assigned to an enemy object reference. There they are, the enemy variables and the enemy methods. Through inheritance, this zombie object can be assigned to an enemy variable. If it looks like a duck, walks like a duck, and quacks like a duck, it's a duck. If a zombie object has all the enemy variables and all the enemy methods, it can be assigned to an enemy object. An interface also guarantees all the methods. So a zombie object can be assigned to an object of type explode me reference variable. Huh? What the heck am I doing here? Look at the red line. Now, this is not an enemy object anymore, and it's explode me object. So I say explode object equals new zombie. Now, why can I assign a zombie to an explode object? Well, I can do that because look at what's in that zombie class. It's going to have the explode me methods. Because it implements explode me, the compiler guarantees that every zombie has all the explode methods that you need. Yes, you can use an interface as a reference variable type. If a zombie object has every interface method, it can be assigned to an explode me reference variable. See why I call it inheritance light? I don't have to inherit a bunch of stuff that maybe I don't want to get the same ability that inheritance provides me. Now, a house and a zombie object have little in common except for the methods in the explode me interface. As the word interface implies, it can be thought of as a communications mechanisms where two or more unrelated objects like house and zombie could talk to each other by calling interface methods. Basically, I'm doing the same example as I did with zombies above. If I build a house object, I can assign it to a shape variable. House extends shape. It's going to have all the shape's variables, all the shape's methods. I can build a house object and assign it to a shape variable. But what else can I do with a house object? Well, think about it. A house object also implements explode me. So I can build a house object and assign it to an explode object. Look closely at explode object. It has all the explode me methods. It's an explode object. Maybe the one method isn't enough. What if we added a method, public function send method? So I kind of squeezed it in here, but this is a second abstract method going in this interface. Now do you see how unrelated objects can talk to each other through an interface? Any object that implements do explosion can then communicate. This explode object would have a send message method. This house object would have a send message method. If the zombie object and the house object wanted to send messages back and forth, since they implement the same interface, you'd guaranteed you have that message and they could start sending messages back and forth. This is one of the true reasons for an interface, is so that two unrelated objects can talk to each other. That's what the word interface means. There's an interface between your computer and the printer, so the computer can talk to the printer. The interface between the land and the ocean is the beach. There's this strip of sand that interfaces the land and the ocean. That's what an interface is. It's a connection between two things. And what an interface does is allows two unrelated objects to talk to each other. In the case of this example, this send message is going to allow two different objects to send messages back and those objects don't have to be related by inheritance. So let's look at a fairly complicated example. Hopefully you can understand it. Here's what we can do with an interface. In the header of method X that I have in a red underline here, it declares it wants a vampire object parameter. This is the header or the first line of method X, and it says I expect to receive a vampire object as a parameter. Now I don't have to write the entire method, but you can assume it's going to use that vampire objects to run the methods defined in the vampire class. So maybe there's a suck blood method in the vampire class. It's going to use this vampire object to execute the method suck blood. That's what a vampire does. All vampire objects have this suck blood method. This is a call to method X. It dynamically creates a vampire object and it passes it as a parameter. When I call method X, I'll send it a vampire object. It's important to note, per the method X header above, this is the only type of parameter the method wants to accept. Method X wants a vampire object, so I can only send it a vampire object. Method X should not accept objects of other type like soldier or werewolf because it's calling vampire methods. They're not going to be there in the soldier object. The only type of object that I should send to method X is a vampire object. Here's a header of a method Y it declares it wants an enemy object parameter. This one's less picky. You do not write the entire method, but you can assume it will use enemy object to run methods defined in class enemy. Methods like attack or set exposition that you know are part of all enemy classes will use this parameter enemy obj and execute those methods. There are plenty of inherited and abstract methods, and now we can pass any object that extends enemy: vampire, drone, mutant. Method Y is much more flexible than method X. Why? Because it takes an enemy parameter instead of a vampire parameter. So it'll take that vampire. This is a call to method Y with the red line underneath it. Boom. It dynamically creates a vampire object and passes it as a parameter. Note, per the method Y header above, it will accept a vampire as a parameter because vampire extends enemy. Method Y will not run all the methods from the vampire class. It's not going to go run suck blood directly. But it could run the abstract attack method, which we know is part of an enemy object, and then attack can execute suck blood. This is another call to method Y. It dynamically creates a drone object and passes it as a parameter to method Y. Note, per the method Y header above, it will accept a drone as a parameter because drone extends enemy, and method Y is expecting an enemy object. Method Y will not run methods directly from the drone class. If the drone class has a fire missile, method Y will not directly call fire missile. But method Y could run the abstract attack method. Remember a few slides ago, the parent class enemy declared attack to be abstract. So all the child classes have abstract. I'll use the enemy object to run attack, and then attack can execute fire missile. Here's a third call to method Y, passing a mutant object. It will accept a mutant object as a parameter because, as you can see above, it's designed to extend enemy, and an enemy has a mutant is an enemy object, it'll take it. This is the power of inheritance and polymorphism. Some call this generic programming, where you can write one piece of code, method Y, that accepts many different parameter types instead of writing many different methods. What we want to do is we want to write once and use it many times. Method Y has the ability to take any enemy object as a parameter, not a specific object as a parameter. That means one piece of code can handle many different objects as its parameter. Interfaces just extend this a little bit farther. Here's a public function method Z. Notice the red underline and the parameter type. In the header of method Z, it declares it wants an explode me object parameter. Now we can pass any object that implements explode me. Did not write the entire method, but you can assume it will use the explode me object to run methods defined in the explode me interface. Go back a slide. The explode me interface had a do explosion. It means I'll accept any object that implements do explosion. Can't really do a whole lot in method Z except call do explosion. What an interface does is it provides the same power of polymorphism does without doing full inheritance. Instead of inheriting a bunch of stuff, so like enemy does, can pass an enemy object, all I have to do is write that one do explosion method. But any class that implements explode me is going to be able to pass as a parameter. Here in the red line, I have a call to method Z. It dynamically creates a vampire object and passes it as a parameter. Note, per the method Z header above, it will accept a vampire as a parameter as long as vampire implements explode me. Method Z only runs the method from the explode interface. It'll say, hey, take this explode me object and execute do explosion. But that method is in vampire and can run any method from the class vampire. I want the vampire object to explode. I just hit it with a grenade launcher and I want that vampire object to explode. Well, that's what method Z will do for me. Furthermore, let's say I'll take any object that implements the interface. This next one is a call method Z, and per the red underline, we're going to send it a house object as a parameter. Call to method Z that dynamically creates a house object and passes it a parameter. Per the method Z header above, it will accept the house as a parameter because house implements explode me. Method Z will only run the method from the explode me interface. It'll execute explode me object do explosion. But that method is in-house and can run any method from that class. Do you see it? Vampire and house are not related by inheritance, only by the interface. But I can still pass them both to method Z because both implement the explode me interface. Looking at the red underline here, we're calling method Z again. It dynamically creates a drone object and passes it as a parameter. Look at the arrow up above. Per the method Z header above, it will accept a drone as a parameter as long as drone implements explode me. Again, back to this idea of an interface as a way to communicate between unrelated objects. When two or more classes implement an interface, it's easy to write code like method Z and have method Z send messages back and forth between the two objects. Finally, this call to method Z creates a tree object. Down here at the bottom with the red underline, I'm going to call method Z and send it a tree object. And it passes that tree object as a parameter. And method Z will accept the tree object as a parameter as long as tree implements explode me. Back to this idea of generic programming. We want to write code that does not care what type of object we're using. Do you want to write 10 different programs that create 10 levels of a game? Or do you want to write one program and give it a different set of enemy and a different set of screen objects and have that one program handle all 10 levels? Inheritance, polymorphism, and abstracts and interfaces allow one program to do just that. We've all played video games here. The only way to write code so one program can handle all 10 letters is to use these advanced object-oriented features. Wow, we're deep into object-oriented programming now. You may be saying, why do I need to understand that stuff? Why not just learn the Unity game engine? Because this is how Unity works. When you understand how a game engine works, you can program a much better game than someone that does not. You need the deep understanding of how object-oriented programming works to really truly understand a game engine. Think about it. This applies to not just computer programming. The people that understand how it works at the lowest levels are the people that are good at what they do. Think about cars. There's different levels of knowledge of cars. Do you know a car well enough to drive a car? Do you know a car well enough to repair a car? Do you know cars well enough to be able to design and create a brand new car? You really have to understand how engines and transmissions and chassis work to really be able to understand how a car works and maybe design a race car. If you have deep knowledge of how a car works, then you can build a car engine. Music is the same way. There are people that know music well enough to play the guitar. Then there are people who know music well enough to be able to write music. Well, it's a whole different level of knowledge being able to write a song versus being able to play a song. And that's the same idea between game programming. You can just jump on Unity and start writing code, but you won't really understand how that code works until you learn things like interfaces and abstract and inheritance and polymorphism. If you really want to get good at game programming, you have to understand how the underlying code works.